Hello everyone, this is the video lecture for Algebra 1314. We're doing chapter 4 now. We're going to start with exponentials and then a whole bunch of logarithmic stuff. And we'll get there eventually. But right now, exponentials, here we go. So exponentials, they just have an exponent. And so that's kind of like saying b to the x. B is your base. X is your exponent. Ha ha ha. X, because there's an x in there. Okay, whatever. Anyways, so I'm going to put this together. It says, hey, use a calculator, and I got Desmos, so that's pretty awesome. And I am just doing exactly what it says. And there's an E over here on this problem. There's an E. So I type E. I don't know. I'm just doing whatever it says. And boom, we are done with these problems. There's nothing else to do. It says 3 decimals. I guess that guy there. Yay, we did it. Bump, bump, ba-dump. There's your answers rounded to 3 decimals. It's pretty easy. Again, just have a calculator available. I think that they have these questions here. Just trying to say, hey, do you have a calculator that can even do that? Here you go. So what does the E even mean? E is not exponential. E is the natural base. But we're going to talk about that a little bit more later. It is a number. It's 2.71828, and I'll prove it to you by just putting E. There you go. So it's just a number, kind of like pi. You know, you have pi as like a number that keeps going. Same thing with E. It's just a special number. We'll talk more about that later as we keep going. Okay. So do you own a calculator? Yes. Next thing here. So notice that they have b to the x. And I'm going to write a capital almost all the time because my little case b's, they look like that. And then they turn into something like this. And then all of a sudden, oh my gosh, it's a 6. No. I'll probably use capitals most of the time. But it's just a personal preference thing. I know my capitals look like 13s. So, sorry. I just can't get away from it. It's one or the other. So it says determine if it's exponential or not. Does it have an exponent, like an x in the exponent? I would say yes, and we're good to go. It says if yes, then what's your base? Your base is 2, because there's a 2 down there. For this guy, same thing. I would say yes. Base is equal to 10. That's pretty easy. This one, no. I mean, it's flipped. X is not in the exponent. There's just a number up there. So that's a no. Just don't do anything about it. This one's an interesting case because you could say, oh, my base is equal to 1. But if you go back up here, it says not equal to 1. So this is one of those technical cases where it's not. I don't know if the homework will actually ask about that thing, but there you go, just in case. Okay, so that was a technical little nuance. And then finally, we have, yes, I have a base of 3. I know that there's more stuff up there, but it works. And then finally here it says -1. Again, I want to say, oh yeah, base is -1. It's not the same as 1, womp, womp, womp. But it also has to be positive. So no. And there's so much I could talk about why this works and why it doesn't work. But honestly, you're just here to get it done, and you're done. So let's move on, okay? Oh, there's a couple more. Yes, because that is a number, and it is a positive number, and it's not equal to 1, so we're good to go. And that's a no, because it has an x in the exponent, but it also has one down here. This is actually called power tower. Power tower. At least I think so. There's not a good name for it, but I think someone came up with that. Moving on. So it says graph these exponentials, and there's a little rule here. Okay, we already saw that. Let's move on. There's a negative in the power means you flip it in a fraction. So what we're doing is 2 to the -3, and it says, what is that? And good thing we got a calculator. So here you go. It's a 1/8. And if you notice what's going on here, over here, if we got 2 cubed, that's equal to 8. So you got 8 and 1/8. And so let's go similarly with a pattern. We got 2 squared is 4. So then this guy would be 1/4. 2 to the 1 is just plain 2. So this will be a 1/2. And then they meet in the middle at 1. What it's doing is it's creating an exponential graph. Exponential. And just for a quick reference, you could just graph this in Desmos, and, well, there you go. So they always talk at 1. They always collide here at 0, 1. And then the next whole number point would be right here, 1, 2. And it's a 2 because the base is 2. It's a 2 because the base is 2. So like if you had a 3, then its whole number next colliding thing would be a 3. You see what I'm getting at here? So whatever that base is where it's going to talk at 1 comma base, basically, okay? So this will always be at 1, and then like the next point would be at 1 comma b, or base, or whatever it would be, 2, 3, 10, whatever it is. All right, cool. So that's exponential, and we often call this kind exponential growth. There is another kind, and I'm just going to put it right here. This is exponential decay, and when it's going down. That would be like, say, 1/2 to the x. What's going on here is that it's halving each time, rather than here it's doubling each time. The 2 means to double. And if you look back at the numbers, you got 1 goes to 2, goes to 4, goes to 8. What's double 8? 16. What's double 16? 32. You're just doubling it. So here, in this case, you would be halving it. And it would get half, quarter, eighth, 16th, da-da-da-da-da. Okay. Oh, look at that. It's right there. So, yeah, this is kind of like reversed because it's already a fraction. If you did 1/2 to the -3, you're actually like flipping it twice. So let me just show you in the calculator so we can verify. See, it's like a whole number 8. So we have 8, and guess what this would be is 1/8, right? So it's like flippity-floppity. 4, 2, 1/2, 1/4. We already talked about this. There you go. This is exponential decay. Okay. Now remember, you need to have parentheses when you do this sort of thing in Desmos because otherwise it's not going to understand. So just keep that in mind. All right. So wall of text. Okay. I can't. Whoa, even more. I mean, this is good stuff, okay? It's good stuff, and I'm going to move on. So they say start graphing it. And really, because this class we're going to be using Desmos, I really will just be using Desmos, and I think that's probably the best way to do it. So I'm going, not with this list, because they did mix it up, start here and go down. So I got this guy. It doesn't look right. I'm just going to do -2 to the -x. Again, I'm looking for this graph here, so no and no. Let's keep going. 2 power 1 minus. Whoa. That's different. See how this has the power? It's all in the power, but when I do minus... So you got to use some parentheses, and look, it's colliding at 2, just like this one is. And yes, at 1, 1 as well. If I can, like, yeah, there you go. Sweet. So yeah, I would say this guy. That's perfect. Same thing here. Again, because we got Desmos, we can go through all the transformations and stuff back from chapter 2. But really, I just recommend doing this, especially for exams. Oh, hold on. It messed up again. Got to put a parentheses. And no, it works. Look, 1/3. That's technically 1/3. So is it colliding here at 1/3? I think so. So, there you go. Sweet. Oh, we already talked about this. So, this is 2.71828. I don't know what e squared is. I don't think that really means anything. I don't really know. There you go. Just so that they're happy. Yay! I'm confused. But this is great. This is a good number. And let's use it, kinda. Okay, so here's a word problem, and we have 2 different functions, and they're saying, hey, we got x is years after 1950, plug them in and see what's happening. Well, this is 1990, and I went from 1950 to 1990, so how much is my x? It's 40, so I'm going to plug a 40 in, and that's the same for here as well, obviously. I'm going to plug a 40 into this guy, my linear, and then I'm going to plug in a 40 into this guy, for my exponential. And that's just going to be Desmos. I'm kind of doing this a little bit differently. If you notice, I'm not doing them individually. I'm going to put it both in at the same time. So I type in my functions, like copy, paste, and then I say x equals 40, because it's the same for both. And then I could write down my answers here. So 8.65. And then 8.966. Now, it's not about being the bigger one. It's about being the closer one. And you can see right here in 1990 that we got 9.1. Which one's closer to 9.1 is this guy. So I would say the exponential is better just because it's closer to 9.1. Okay, that's what they're wanting. All right, compound interest. So this is a brand new topic. We're just going to go through how to make this thing work. It's a big formula. You plug it in, you're done. This is the main one. This one's good later. I would honestly switch them because this one's way more important. Let me give you a definition for all the different letters, and then we'll go from there. So A is your final amount, like after a long time. Compounding interest, that's like, okay, pause. So you got a lot of money, let's say like $10,000, and you go to the bank and you say, hey, bank, can you take $10,000 from me? And they're like, sure. So they take $10,000 from you, but then they promise to give you more back later. Like in another 5 years, they hopefully will give you like $11,000. I don't know. Depends on the interest rate, and it's not very high right now. It was for a little bit, but now it's gone down a lot. But anyways, the interest rate is determining how much more money you would have later. So you're giving the bank some money, and then later you would get some more money out of it because you gave the bank money to play around with, and banks play with money, and that's what they do. Anyways, so that's what the formula that you both use to get your money out in a couple years. So P, so that's your A is your final amount. Afterwards, P is called your principal, and this is your starting amount. I'm just going to put start. And then you have R is your rate, and this has to be in decimal form. When we get there, I'll show you. And then T is the number of years. Okay, and honestly, you know what? I want to copy paste that over here because all those letters are being used here. What's new is the N. Okay, so the N, I don't have enough room, so I'm just going to put it down here. Sorry. I would honestly switch them now that I'm looking at it. But what did I do on my workbook? I wonder. You know, I'm just curious now. You can't see it, so even if I messed up, I would, oh, I did do it that way. I switched it. All right, well, whatever. I would switch them. So I would switch these and put this here and that there. So get your eraser out. I don't really know. It's blah, blah, blah. N, what does N equal to? So N is the number of times compounded per year. Compounded per year. Okay, so let's talk about this. So you go to the bank and you give them money and they say, oh, we're going to go and look at your account and give you some money back. Not just at the end, but every year, every month, every day. It kind of depends on what the agreement is. So let's just say that they use the word annually. So then that's going to be one time a year. How many times per year? Semi-annually means 2. So they're going to look at it 2 times a year. Quarterly, how many quarters are in a dollar? Exactly, 4. I think there's weekly is 52, but we're just going to skip ahead. Monthly is 12, and daily would be 365. Is there a eraser around here? Yeah. Go away. Go away. I'll just make it into an arrow. Boop, boop. There you go. 365. Blah, blah, blah. It just depends on what you're doing, okay? So swap those in your notes. Sorry. So, see, I just got caught up with myself. That looks so cool. Let's go and do it. And we will. But then there's this new one here for continuously. That basically means infinity. So they're looking at your account infinite amount of times, giving you money back every minute, basically, which is cool. It sounds like you get more money, and you do, but it's not as much as you think. And I'll show you and compare with this problem. So basically, in the end, it's just a really big formula. You toss it in and you're done. So you start with $15,000 and you want to put it in a bank for 7 years, and you got a 6% interest rate, which is awesome. At least for us putting money into the bank. If you're like wanting to buy a house or a car, that's not. Well, I mean, a car not too bad, I think. I don't know. Does cars go 1% or 2%? Houses are only like 1. Moving on. So I'm going to use the big formula for most of this problem. And they say, first off, semi-annually. So that's going to be n equals 2. So I'm going to do n equals 2 and plug it all in. So I got $15,000 times 1 plus. My rate is 6%. So notice I put it in decimal form. 2 times a year, 2 times the 7 years. Calculator, here we go. Typity, typity, type. Okay, hold on. I did something that you didn't quite notice. You see, I put a 14 up here, which is good because 2 times 7 is 14. Good job. But if I did 2 times 7, oh man, not again. You see how it's messing up? If you're going to do that, you have to use parentheses, which is kind of annoying. So I just say like 14. So don't mess that up on exams and stuff because that would be like really sad. There you go. So with a 6% interest rate and you're putting it into the bank for 7 years, you get $22,000, almost $23,000 at the end of 7 years. That's pretty good. Again, though, it's 7% interest rate, which is like super awesome for us putting money into the bank. I don't know if that's still around, but this is great. We like this. This is good stuff. Okay. So let's keep going. It says now quarterly, so n equals 4. I'm going to basically just repeat the process, but everywhere there was a 2, I'm now going to put a 4. 4 times 7 is 28. Exactly. Wait. Did I mess something? Oh. There's a 4 right there. My bad. Because I was like looking at that number like, that's a lot. No. 2, 2, 7, 5, 8. It should all be very similar numbers. If you notice, they're both 22,000 essentially. You'll get 22,000 all the way down. It's just a little bit more because you put a little bit more. They check it a little bit more often, so they give you money back a little bit more. That money accrues more interest. Yada yada. Money. Okay. And then we got monthly is 12. And so I'm going to do the same thing again. And this time we're going to go 48. I messed something up again. 4 times 12 is 48, isn't it? 12, 6. Oh. Why am I doing 4 times 12? It's 12 times 7. Oh my gosh. Math. Okay. I feel silly. I'm so sorry. So 22,805.54. And notice that I stopped and paused. I said, hey, that doesn't look right. It should be around 22,000. That's the point. You got to make sure that you're around that same number every time, okay? So it says right here continuously, which means infinity, but it just means that you're going to be using the PERT formula. So that we call this the PERT formula. Okay, I call it the PERT formula because it looks like PERT. But it's just that formula up here, right there, the PERT formula. So I'm going to just plug it all in. So 15,000, and then I got, hold on, e to the 0.06 times, time is 7. So this should be the very highest amount that we could get at this rate for that amount of time, because they're looking at my account, again, all the time to add money back. There you go. And again, I'm still expecting about the same thing. So 22,829.42. There you go. So the difference between twice a year to like infinite is, I don't know, $100-something bucks. It's not that much. I would go with the bank and the interest rates and the stuff that makes the most sense for you, customer service and all that stuff. And leading into our next problem, same kind of problem. We have $14,000, and we're going to go to, and we got 2 years to hang out. We're going to go to Bank A, and we're going to go to Bank B, and we're going to see which of these banks gives us the better option. So I'm going to test them both out. 14,000, and then I got 1 plus 0.06 for, hold on, quarterly is 4 times a year, 4 times a year for 2 years. So that's my first one. My second one is going to be the different rate, if you notice. So I got the 14,000, but my new rate is the 0.594, and then again for 2 years. So I want to see what both of these yield in Desmos. So here we go. Okay. So they don't ask what those values are, although I really would just write those down in your notes. but they're saying which one is the better one. There's a 3 technically. Well, this one's better by a little bit, so that's technically the correct answer. I don't know. They're both really close, and they should be. Okay, cool. And what? That was it? That was it! This is actually a pretty easy section. I think there's a couple more applications on the homework, but again, I'm just doing the workbook here. I have other videos for those other problems. So just the workbook. The workbook's done. We're good. We're done. Thank you very much. Have a great day.